Hi everyone, welcome back to Data Cadence. My name is Rahul and I work as a senior applied research scientist. And in this video, we'll go over another important interview question, that is why use CNNs over ANNs, that is artificial neural networks, for image understanding use cases. Now, this question is probing your understanding of why convolutional neural nets are preferred over artificial neural networks for certain tasks, particularly in the domain of, say, image processing and computer vision. And CNNs, like we know, is a very popular choice for image understanding use cases, and it's inspired by the biological human visual cortex. And if you have used a CNN ever in any of your projects, be it in the industry or any personal side projects, it's important to understand because this tests your fundamental basics of whether you understand what a CNN does and how does it work. So yeah, coming back to the question, why a convolutional neural net over an artificial neural network for image understanding? So there are multiple reasons that we will talk about. So let's talk about each one of these. So the first one is spatial structure and local connectivity. So when it comes to artificial neural networks, they would treat every input feature as independent. So they do not consider the spatial structure of your data. And what I mean by that is, let's say you flatten an image into a 1D vector. So an artificial neural network would lose the 2D spatial relationships between the pixels, which are very crucial for understanding images. And on the other hand, CNNs would use convolutional layers that apply filters or kernels to small regions of the input, preserving the spatial relationships. And this local connectivity and spatial hierarchy is what makes CNN powerful for tasks like image understanding. The second thing is parameter efficiency. This is very important and pretty intuitive as well. So ANNs would typically require a large number of parameters to process high dimensional data like images. So say for example, you have a colored image of dimensions 256 cross 256. So in this case, the total number of input features would be 256 times 256 times 3, since it's a colored image with 3 channels, say RGB. And that would land you up with 196k parameters, and these are the number of parameters for each of your neuron in the entire in the entire sort of parameters when you look at one single neuron. And if you were to do this for a moderately sized fully connected layer with 1000 neurons, so the total parameters for a single layer would come close to 196.6 millions, and this is just for a single fully connected layer. Now assume that you're training a deep neural network and you add more layers to your particular architecture. The number of parameters will grow exponentially, and essentially what this will lead to is first of all overfitting, because the model may memorize the training data rather than generalizing on the new data. It will also lead to a computational inefficiency because training such a model would require significant computational resources as well as time, and high memory consumption as well, because storing and processing such a large number of parameters would demand substantial memory, right? So all in all, ANNs are very much parameter inefficient when it comes to images. And on the other hand, CNNs would use shared weights via filters or kernels across the input, and this would significantly reduce the number of parameters that you have. And not only it makes CNNs more efficient, but also allows for a better generalization with lesser training data. The third one is the translation invariance, and what we mean by that is the ability of a model to recognize an object in an image, no matter where it appears in that particular image, without needing to relearn it for the different positions. And ANNs again lack the ability to recognize patterns in different spatial locations of the input data. So, for example, if an object in an image shifts slightly, an ANN might struggle to recognize it as the same object. And in case of CNNs can detect features regardless of their position in the input. So thanks to pooling layers that we have as a part of the CNNs, which introduces a degree of translation invariance. And the final point is hierarchical feature learning. So ANNs would treat every layer's output as independent, making it hard to learn the hierarchical representations of your particular data. And in case of CNNs, they can easily learn the complex features hierarchically, from simple edges in the initial layers to more complex structures like textures and objects in the deeper layers. And this hierarchy is essential for understanding the high level content of your images. So if I were to conclude, while ANNs are pretty versatile and can be applied to a wide range of problems, CNNs are specifically designed to handle the spatial structure of images, and the architecture of CNNs allows them to be more efficient, effective, and accurate for tasks in computer vision, compared to artificial neural networks. So hopefully this was a very short video, but often if you would have used CNNs in any of your projects, you should know this fundamental difference because it depicts the understanding, the basic or the fundamental understanding of CNNs. And this will also be very handy in case an interviewer asks you why you would want to use CNN over ANN for the image understanding use cases. So hopefully this video gave you some more insights into this particular topic. If it did, please consider pressing the like button and subscribe to this channel for more such content. See you in the next video then. Until then, stay safe, take care and keep learning.